Assalamu alaikum. We will be continuing with our previous lectures. Today we will be actually doing more of the examples. We won't be covering much of the new things so that we get the concepts, because the benzenes reactions and like so far all the reactions we have learned, there are, like I would say actually, like frankly, there are actually so many conditions to be fulfilled and to be remembered. So it would be better if we do a couple of more examples. So inshallah, we will be dedicating to this class for doing those examples and observing how such questions could be solved. Thus, at the same time, we'll be also observing some tricky bits of corners where like Cambridge tends to give sort of questions. Okay, so without further ado, let's begin our today's journey. So our first example of today would be, so let's say we have this benzene ring. And we have a alkyl group and a Br or bromine attached or bonded with this let's not give this one, let's do it in a different way. Let's say we have initially initially we have bromine here. Yeah, that's better. Now let's say over here, when we add concentrated nitric acid with it and concentrated sulfuric acid at 55 degrees centigrade, I'd urge you, before continuing with today's class, go through the previous lectures. So it will be very helpful for you in order to like recall, okay, which condition is this, which reaction will it be performing, as well as like what will be the products. So it will be much more easier for you. So after this reaction is done, this will be the product given. So actually here is happening what? It is nitration of benzene. So this is the benzene ring, and there will be our nitro group, and this is the bromine. This is the product like they have given this part, and as well as they have given this part as well, that after adding these conditions, here's the reaction. This is the condition for what? This is the condition for our electrophilic substitution, isn't it? Electrophilic substitution. This is, I'm just writing for like showing you like how to actually solve such questions, so that like you can recall, like active recalling. Okay, so this is actually a way of like remembering and revising by yourself. So this is the reaction of electrophilic substitution, which is the characteristic reaction of what? Benzene. And this is specifically the nitration of benzene, isn't it? So now, after this product has been formed, when we add, let's say, tin in this place, tin with concentrated hydrochloric acid, HCl, and give some heat, some product should be formed. That is what we are supposed to draw here. And from that product, when we add further, let's say CH3COCl, which is an acyl chloride, if you feel like certain products you are unable to recall, then as I have said, like the name of this, let's say this reagent, try to write the name as well, like beside by giving a, let's say in this case, I have told that this is an acyl chloride. So right beside that this is actually an acyl chloride. To be more specific, this is actually methyl chloride. Methyl chloride. Why? Because we have a methyl group, alkyl group, and like chloride group or acyl chloride group. Now, here the bromine stays intact, and this product should be nitrogen bonded with a hydrogen. There's this carbon, O and CH3. So what it is being showing here, that after reacting over here, we don't know what was the product here, but we have to find it, and we got this one. So can we find this part? This is actually over here. Okay. Now there is some other direction of the reaction as well. This is, let's say, the initial position. Okay, the starting. This is the starting position. Okay, so from here there could be like the upward direction, like another way of reaction. If we initially add the reagent, let's say CaCCl, and do AlCl3 and hydrous condition, it would be producing this product. So initially, which like at the beginning of the class, I was actually drawing this one. So without having this one, like this benzene over here, it would be like, it won't make sense like how this came here. So observing in the reaction, it is now easy to understand that this is actually what? Electrophilic substitution as well. Specifically, this is a free radical, sorry, this is actually Friedel-Crafts alkylation reaction, isn't it? This alkali, it's this alkyl group has been attached to the benzene ring or the benzene molecule. Now from here, when we add H plus and H plus with KMNO4 and apply some heat, we tend to get some certain product which, when added with PCl5 at RTP in temperature, we tend to get some other product which also we need to find. And on that product, when we add CH3NH2, we get this molecule, which is our Br, and oxygen, nitrogen, there's this hydrogen, and there's this CH3. Okay, don't confuse this one with that one. It's a different product also. Sorry, I forgot to give a benzene ring here. So this is a different product, that's a different product. Like over here we came here like this way, and on this, like to this product, we came here in this way. Okay, so let's try to solve it. I would urge you to pause the video and do it by yourself. Like try for a few minutes, let's say 5 to 10 minutes. Do it, try it by yourself. Even if you don't get it, then like see the like walkthrough. Okay, so I hope you tried. It's completely fine even if you didn't get it. At least try it yourself and see the conditions, which are which conditions. Understanding what condition is that, like what type of reaction is happening there, is much more crucial than actually being able to solve. Okay, once you are able to like identify what sort of like reaction, like what sort of reaction and what conditions are there, it will be much more easier for you to like proceed. Okay, so here at first we have this benzene ring. Let's forget about this bromine. Okay, it is not actually affecting that much, because without this also, like having it here, also not having it here, is the same thing as like having a benzene here. Okay, because see, when we added nitric acid and sulfuric acid, we are requiring 55 degrees centigrade. Like this is the condition for what? Nitration of benzene. But we also saw the reaction for, or the nitration reaction for phenol as well, isn't it? In phenol, what happened? We didn't require any like harsh condition like 55 degrees centigrade, no sulfuric acid, and even only like nitric acid was enough, not even concentrated nitric acid. Okay, now see here we needed more like more severe condition with high temperature, concentrated acids. After that, this reaction was like this reaction took place, but other than that, this reaction didn't take place. That means it shows that this reaction is actually like identical to the reaction of benzene, so it acts as a benzene molecule. Okay, so let's consider this is the benzene. There we are getting electrophilic substitution reaction at these conditions. Now when we add tin plus concentrated hydrochloric acid and heat, what is this reaction? This is actually what? Formation of phenylamine, isn't it? If we go back to like if we go back to the previous class lectures, you would see this is actually phenylamine. Phenyl, like the condition for phenylamine, phenylamine. Okay, phenylamine would be produced here. So phenylamine would be what? Like this oxygen will be replaced by hydrogens. So we would be having bromine here and NH2. Now if we add, like in this case, this is what? An amine group, and this is alkaline, a basic group. alkaline group, isn't it? This is alkaline, not acidic, alkaline. Alkaline, yeah, alkaline. This alkaline and this acyl chloride is sort of acidic. Okay, this is an like acidic type of solution. When they tend to react, what happens? This chlorine, this hydrogen, remember formation of amide linkage we studied in the last class, amide linkage, like formation of amides. So there, what did we see? Also acyl chloride reacts with this sort of like this sort of phenylamine. And when they react, that one of the hydrogen, one of the chlorine, like one of the hydrogen from here and this chlorine, they get separated and form HCl, as well as this amide linkage is formed, isn't it? So see, this amide linkage is formed and the rest remains same. So this is the reaction happening here. And on the other side, let's see, this is actually what? This is electrophilic substitution, but to be more specific, Friedel-Crafts alkylation, because this alkyl group is added here. So after that, when we add H plus and KMnO4 with heat, what is happening here is actually hydrolysis is happening. Sorry, not hydrolysis, oxidation. Remember oxidation of the side chains? We learned in most probably in second or maybe second or third video, or yeah, maybe second or third video, most probably. So you would see in one of the lecture note, you would see that when this sort of conditions are provided, the alkyl group or the alkyl group, like whatever the alkyl group is present on the side chain, that will be converted into what? Carboxylic acid, remember? So this will be converted into carboxylic acid. Let me, for simplicity, for your convenience, let me just see it a bit. Yeah, oxidation of side chain of benzene to make benzenoic acid. So you'd see it in most probably in the second classes lecture, I guess so. Second, third, fourth, yeah, second classes lecture. Inshallah, we'll be able to see it in second classes, like second organic chemistry lecture. Then, I mean the second part of organic chemistry. Then we have what? PCl5. When we apply PCl5, what is going to happen is simply this carboxylic acid, it is going to get like the OH group from the carboxylic acid. This OH group is going to get displaced by what? This Cl. Okay, so this will be the reaction. We have bromine here. Bromine remains like totally intact, no change in this case, and we'll be left with this one. This is sort of an acyl chloride, you can say, another acyl chloride. So our chlorine is like replaced over here. Okay, now when chlorine replaces and when we add CH3 and H2, what is happening over here? This is equivalent to our another like amide linkage, formation amide, isn't it? This is another acyl chloride, and here we have an amine, sort of like alkylamine. This is methylamine. So methylamine and this acyl chloride, they're going to react by removing chlorine from this molecule and removing a hydrogen from this nitrogen, and see formation of again this amide as like this one, but in the other direction, like in the opposite way. Now in this case, the carbon bonded with the oxygen is with the benzene ring, but here the carbon bonded with the oxygen was with which one? Nitrogen, not with the benzene ring. Okay, but not with the benzene molecule. So this was this example. Okay, this is actually for, yeah, so these are the our final solution. Okay, so I hope you got it. Now let's do another one. So let's say we started from, yeah, we started from an unknown molecule. Now it's a bit tricky, but you have been given the molecular formula of this molecule, okay? And when we add H plus and KMnO4 and some heat, you should get COOH over here and COOH over here. From here, when we add PCl5 at RTP, we should be getting COCl, COCl. Now, further down the line, when we add with it CH3, CH2, NH2, we should get what? We should get this carbon double bonded with nitrogen and hydrogen. No, I shouldn't have drawn that. I'm sorry. So this is actually what we need to draw. So let me make it a bit bigger. From here, when they have provided LiAlH4 in dry ether, ether is another organic substance which we don't have in our syllabus, but we tend to like study, like we tend to have some basic knowledge. Ether is sort of this molecule where carbon, oxygen, and carbon, like this sort of molecule, like this sort of bond, for example, let's say here are some, we have other like other substances, and here also have other bonds, but the bond which contains this carbon oxygen bond, okay, this sort of molecule is known as the ether group. Now when we add LiLH in dry ether, we tend to get this product. Okay, so this is basically it. Now I would urge you to try to solve it by yourself. So basically, what can we see is actually, see this condition. Obviously, here we have a benzene ring, isn't it? So benzene ring, that means on the previous side, there should also be a benzene ring. What sort of thing can we understand? We have, after adding this reaction, what is the product we are having? We are having actually a benzene molecule with 2 carboxylic acids. Now, is there any chances from like previous molecule, like whatever the molecule it should be, after adding this, what sort of reaction benzene tends to have? Remember oxidation reaction? So that means it would be easier for us to guess actually whichever like side chains will be having carboxylic acid, that should be replaced by our like alkyl group, isn't it? So let's say that means we're for sure now confirm that here we have an alkyl group and here we would have an alkyl group, but what should be the like size or the length of the alkyl group? Now see, one thing we can take help from is this molecular formula. We have already how many carbons here? 1, 2, 3, 4, 5, 6 carbons. Yeah? How many more carbons do we need to fulfill this molecular formula? More 2 carbons. That means on each side we can have 2 more carbons, C and C. Here for each carbon we have 1, 2, 3, 4, 5, 4 hydrogens. But we don't have any hydrogen over here. Why? Because the hydrogen bond is replaced by these carbons. Isn't it? Okay, so that means we have only 4 carbons. That means more 6 carbons are needed to be like introduced here. That means if these are methyl group, we could have 3 carbons, 3 hydrogen here and 3 hydrogen here. That means that fulfills our, in total, the 6 hydrogens. So that's our first component. Now, after this was added, this was our oxidation to the side chain react, like side chains of the benzene molecule to form benzenoic acid. This is actually dibenzenoic acid because 2 carboxylic acids are formed. Then when PCl5 with RTP is added, these OH groups are replaced and chlorides are added. Now, when we add CH2 NH2, we can obviously like understand actually what sort of reaction will happen here, because we know we have seen from amide, like the formation of amide, that when COCl actually reacts or carboxylic acid reacts with amine, they tend to form this amide linkage. Both COCl, like acyl chloride and carboxylic acid, performs this reaction. Okay, but what should be the product in this case? Let's take help from this portion. Like what is the after reaction and what is the before like reaction? Like from this product, there is a component like after like further reaction, this is the product form, and before like for forming this product, the previous step, what was the reactant? So we can observe that over here, this was the case, and also there should be one more thing given, like the molecular formula of this one, which is C10H9NO2. So if you have tried it already and you couldn't you couldn't solve it, try to do it now again, because I forgot to give the molecular formula. So I urge you to do like more 2 to 3 minutes or 5 minutes on this case. Try to make sense if it is possible or not to, like, for you to make it. But we would move forward now. When CH2 NH2 is added, now let's see actually what are the conditions here. See here, two SL groups. That means both can form amides, or both will form amides. But see, in this molecular form, like this could be possibility, isn't it? This could be a possibility. C double bond O, N, H, and we have CH2CH3. And in this case, we have carbon. Again, like this is the same structure, isn't it? Because we have the same molecule and this way, isn't it? But see, only one molecule is provided. Also doesn't matter, it could be many more molecules here, but see the molecular formula, only one nitrogen is given. That means we cannot have actually two nitrogens here, isn't it? Also see the other rest of the formulas. Here we have 1, 2, 3, 4, 5, 6 carbons, 7, 8 carbons. Yeah, 9, 10, 11, 12 carbons. But see how many carbons are there? 10 carbons. That means we have 2 more extra carbons. That means one nitrogen is eliminated, 2 carbons are eliminated. Now let's see about hydrogen. Over here we have 4 hydrogens for these 4 carbons, because these 2 carbons are bonded with other carbon, like this carbon, so they cannot have hydrogen. And over here we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16 in total hydrogens, but they have given us 9 hydrogens. That means 16 minus 5 minus 1. So they're eliminating 5, 6, in total 7 hydrogens are being eliminated, isn't it? That means we cannot have 7 hydrogens here. How many? 1, 2, 3, 4. Yeah, 5, 5, 10, 12, 16. Yeah. So that means now one thing we can notice, once let's say we have this sort of, let's say, amide group. Okay. Now again, let's say we have another this acyl group. What can we do is this this acyl group can react with this hydrogen. Okay, and they can replace each other. I mean, they can like form bond with each other and get eliminated. Now when they get eliminated, what happens? There can be another amide linkage. Okay, like, did you get it? Let's say we have this acyl chloride, some acyl chloride plus NH2. Okay, that means this nitrogen hydrogen amine group. Okay, now this hydrogen and this chlorine, they react with each other and tend to form this bond. Okay, just I draw this hydrogen like to the bottom side. Now after this is formed, if let's say another acyl chloride tends to appear here, what it can do is this hydrogen and this chlorine, they can also do the perform the same reaction, and they could perform, or they could form another amide linkage. Okay, like this won't be now any amide linkage because nitrogen doesn't have any hydrogen, but this reaction can actually take place, and the nitrogen will be having forming bond with will be having this other substances here, but no more hydrogen will be left over. But this can also be formed. Okay, in both this case, see one nitrogen is we can have both the acyl chloride reacted with one nitrogen. That means this is possible. So same sort of reaction can actually take place in this case in our condition, in the reaction they have provided us with. So over here we can have actually, just a minute. So actually this won't be the case. The reaction should be rather looking like this. So this is our the benzene structure. From here, we have this carbon, and we also have this carbon. The same, like these two acyl group, one will form reaction with this nitrogen, and there will be this hydrogen and other CH2, CH3. But at the same time, this acyl chloride would also react with this hydrogen and form this bond. Okay. Now this nitrogen will be left with what? Our CH2 and CH3. Got it? So this is actually our next product. Now from here, see, when we add AlH4, what is happening? This is actually reducing agent, a reducing agent. Now what does it do? It eliminates the oxygen from this position. Okay, that's what it did. So this is actually causing the elimination of this oxygen from this portion. So it is better, like they didn't ask you about this, but it's better for you to know actually what is happening. Okay, so this is actually a reducing agent. So LiAlH4. Also, if in place of LiAlH4 they would have given, let's say, NaBH4, this is lithium tetrahydroaluminate, and this is sodium tetrahydrobromate. Yeah, the last class I couldn't recall what was the name. This is actually what this was. This is actually boron. Yeah, boron. Yeah, so sodium tetrahydrido, is it borate or bromate? Something, again I forgot, so I would try to recall it and say it to you. But yeah, so that's our product so far. And now let's do another one. I hope you got that example. If you didn't, then try to rewatch the example, solving of the example. It will be easier for you. Now let's say we have here this component, and do we have anything else here? Yeah, let's say this is our initial component, and from here we are adding onto it CH3 CCl, okay, in AlCl3 anhydrous. Or this can also be given in, let's say, skeletal formula. Like this structure could also be given, let's say, in skeletal structure. So I'm, for your simplicity, drawing the skeletal structure. So try to also draw it by yourself. Why is it like this? This says CH3, that means 3 CH3 groups are here and a chlorine group. Now when they react, they tend to form certain reaction. Now what are this reaction, what are these conditions in place? So one of the condition I have written here for you. So the next conditions, you should be writing it by yourself. So sorry, there was another descent here. I forgot to give it here. Now from here, we should be getting this. And after something being added, some other conditions, we should also be getting, say, this. Now our work is to actually find this or write these conditions which can actually form these products. Now the first one I have given already, which is, we can see that actually this group is being added here. So actually what can be present here? So an acyl, this is actually Friedel-Crafts alkylation. So this is the alkyl group which will be adding. With that, a chlorine will be added. So that we added a chlorine and the condition for Friedel-Crafts alkylation. This is actually an electrophilic substitution reaction. Now after that, what do we have? We have this group being added, isn't it? So after adding, like, since this group is being added here, what is happening here in this case? We can say that this is also another Friedel-Crafts alkylation, but in this case, what is being added? CH3. Let's see, what is this molecule? We have a CH3. This is C. This is O. That means CH3CO. And in this case, a bond form, that means there should be a Cl, isn't it? So that means you can write it here, CH3COCl, the acyl chloride with AlCl3 and hydrous. Okay. Now in the next reaction, we will be having, wait, this, yeah. In the next reaction, what we're having is 2 nitrogens are added, isn't it? So see, this is actually what? Nitration of benzene. Now, why it's nitration of benzene? We also learned about nitration of phenol, but see, here is no phenol group. So whatever it is, if no phenol group is present, then the reaction should be nitration of benzene. Okay. So the nitration of benzene's condition is what? Concentrated HNO3, concentrated H2SO4 at 55 degrees centigrade. Okay. So this is our reactions. Now let's do the next example. We are having, let's say this is the initial molecule given. So they can tend to give you different sort of like reactions. Okay. From here, let's say we will be forming this one. So now in this case, they will be asking you several type of question. Let's say here they're asking you to give the condition in this case again. Then from there, they are giving you, let's say this is the product, and they are also saying you to give the condition in this case. And from here, they're saying we are now giving you this NaNO2 HCl at 5 degrees centigrade. Now draw this product whose molecular formula they haven't given you, but when this is like done with something, they tend to form this. Oh, it's okay. Now let's see. Try it by yourself at first. If you can't, then we'll be solving it together. So in the first position, in the first case, we are having some sort of what? Let's see. Over here, a benzene, a nitro group is added. See, there is no phenol. That means this is what? Nitration of benzene. And nitration of benzene is, we know, concentrated HNO3, concentrated H2SO4 at 55 degrees centigrade. Like, give the space according to whatever you require, how much space you require, and then write it. Then in the next reaction, see, nitrobenzene turned into what? The phenylamine. That means this is a phenylamine reaction, and we know the concentrate condition for phenylamine is what? Adding tin with concentrated HCl, and then we have what? Applying heat. Yeah. Now, after this reaction, we are getting what? Sodium nitrite is being added with HCl at 5 degrees centigrade. We know this reaction, isn't it? If you can't remember, then try to go back and see that the formation of benzene diazonium chloride. So this is the reaction of benzene diazonium chloride. So this is completely just like whatever is given like in the lectures, whatever is like being taught. Like, this is simple reactions. Nothing like too fancy is given here. So these are the reactions we already know. So due to this reaction, what will be formed? This will be the product being formed. So N, triple bond N, this is our plus sign, this is, and minus sign, chloride. Okay. And like you can, for your simplicity, you can also write that extra, that this NO2 is being eliminated. This is like, they didn't require you to write this, but I'm just writing it for your knowledge, like for letting you know what is happening. Now, when we add, what will cause the formation of this phenol? Now there is the presence of phenol, isn't it? Now, how did you perform this phenol? Don't mix it with an alcohol, because this is not an alcohol. OH group in benzene is known as what? Phenol. Okay, so this is a phenol group, and we know when we add water, that means when we hydrolyze it in presence of water and heat, phenol is formed from benzene diazonium chloride, isn't it? So this is the reaction. Now let's move on to the next one. So let's say we are having, let's say we're having this molecule And there are certain conditions that have been like provided that this sort of reactions are happening, or this like we are applying these conditions here. We need to identify what will be the products. Okay. Now try it by yourself. If you can't, then we'll be like doing it together. Now see, when we add HBr, okay, this is what phenol, which is acidic. HBr is what? Same as HCl. HCl is acidic. HBr is acidic, but they're acid, isn't it? So actually, there will be no reaction here, because acid and like acidic and acidic substance, they don't tend to react together. So no reaction. Now, when we add sodium, we know phenol reacts with sodium, isn't it? Try to see previously, like previous notes that like the like organic chemistry of A2 like A levels or A2 notes that we studied. Phenol reacts with sodium, and they tend to form this structure. Like they tend to simply react as like an acid with sodium, like acid and metal. So this is the product being formed. Sorry, this condition shouldn't be written here. Here, NaOH aqueous. Yeah. So this was the product for sodium, and we can say that hydrogen is being eliminated. Like I'm just writing it for simply this is the byproduct. Okay, you don't need to write it. I'm just for the knowledge, for the like recalling of the like the lectures what we studied. So that's why I have written here. Now over here, when we add sodium hydroxide, this also acts as the same way. This is an acid, this is a base, so some acid base neutralization reaction occurs here, and the reaction should be, this is our ONA, Na plus and O minus, with some byproduct of water. Okay, got it? So this will be our reaction. But let's say this wasn't the case. Okay, let's say this benzene ring was not given. Then what would have happened? Let's say we had this structure, a simple hexagon, and we have this OH. Now what is this? Now they can trick you. This is not no more a phenol. This is what? This is an alcohol, cause that we don't have a benzene ring. Remember I mentioned no benzene ring, no phenol. Benzene ring, phenol. Okay. Now no benzene ring, that's our alcohol. Now when we add HBr, okay, HBr, this is going to simply what? Nucleophilic substitution reaction. There's just going to be added Br, and we'll be having this one. So water will be like eliminating. And when we add Na with it, what happens? This also going to react, because alcohol reacts with sodium. So alcohol would react with sodium, forming this ONA, okay, plus half H2. This reaction remains same. This is half H2